Hello everyone, this is the next testing fundamentals session where I will be covering the testing process, and within the testing process I will be covering test planning and test execution. Just to recap for you, this is the software testing life cycle which we had gone through in our previous sessions, which is identifying requirements, strategy and design, planning, execution, then defect tracking and bug fixing, finally review and audits. Looking at the software testing life cycle, the phases are test planning, test analysis, design, test execution, and finally closure. So we discussed the roles and the phases along with the outputs. So let's just going back to them again. In the test planning phase, the team leader or the project manager or the project lead creates a test strategy and test plan. Test analysis is done by a team of test engineers or test analysts based on the system requirement specifications and the functional use cases. Thereafter, you do test design. The output of this is the test scenarios, test cases, and the test data, right? The next stage is test execution, which is also done by test analysts and test engineers. So you test the system, that is execute test cases, find defects and report it, thereafter do retest. Finally, the last phase is test closure, wherein the project manager or the team manager creates test summary reports. So what is test planning? It is designing your test cases, the strategy, and understanding the requirements, and it also includes the testing resources, right? The testing policy and the test strategy is generally at the company or the project level. You create a high level project plan for each project where you decide what you're going to test, how much you're going to test, and you'll also have entry exit criteria for it defined at that level. Then you'll have a detailed level test plan for the component, system, various types of testing which you're going to do. Parts of test planning. So you have a scope, then you decide test strategy, you decide the entry exit criteria, then you decide the skill sets you require for this. You also decide the environment needs, test deliverables, test scripts, and then scheduling. You also have risk management. So these are all the parts of the test planning, and you start from scope. So test planning includes defining the overall approach, coordinating test activities into the software life cycle, defining the level of detail, structure and templates for test documentation, monitoring and controlling test preparation, and making the most important decisions of what to test and what roles will perform which test activities. So you have an exit criteria in the test plan, which I have been mentioning over all these training sessions, it mainly consists of what is the time when you're going to stop testing. That is what you're defining in exit criteria. So you can say your exit criteria is no priority 1, 2 and 3 defects, say 10 priority 4 defects and 5 priority 5 defects. These are agreed at the project level with the client. Now there are lots of risks which have to be considered in a test plan. So one of those risks is failure of a third party to deliver your third party applications on time. Suddenly you have a staff shortage, or you have training issues, or you have some technical issues with respect to defining the right requirement, the quality of the design and the code and the tests, etc. So you have to analyze the project risks, and you have to have a risk based approach to testing, so that you reduce the project risks in the initial stages of the project itself. Now let's come to test designing and execution, right? When you design test cases, you have to identify conditions, that is, you're specifying what your test case is, right? So you identify conditions, you design test cases, and you build the test cases. Now for this stage of, say, black box testing, you will use equivalence partitioning and boundary value analysis. So that is the test specification. You're specifying what are your test cases. A good test case, what should it contain? It should be effective and it should be very clear, okay, and you should think of a test case from an end user perspective, so you can find faults and it is easy to maintain. Okay, a test, you need to identify design and build, right? So you have to determine what is to be tested, design how, what you picked up in the previous step, the step 1 is to be tested, and implement the test over there. So you identify conditions which you like to test. For example, we had $10,000 to $15,000 in our previous training session. So you say $10,000 to $15,000 is a system attribute, so you have to test for data less than 10,000, at 10,000, 15,000, just above 15,000, and within 10 to 15,000. You have to prioritize the most important test conditions and ensure that they all are covered in your test cases, or you will not find any defects, right? So for selecting test cases, if you plot a graph, right, the first set is importance, and the second set, if it's on time, the best set will be a good mix of everything together. When you design test cases, a single test case may have one or more test conditions, and you have to predict what the outcome of putting that test condition in your application is going to be. So you have to have an expected result, the precondition for that step, and also what is the actual step. So the most important test conditions in this graph are plotted there in red. The least important test conditions are plotted below, right? So your test cases should cover all the most important and at least some least important. So while preparing test cases, you have to have very detailed level test cases. You must have the test data detailed in the test case itself, and you should also have noted down the expected result. Test execution, right? Now you execute the test cases which have been defined for that release. Okay, you always will execute the most important ones first, and you can either do it manually or you can do it through an automation tool like UFT or Selenium, etc. Okay, you would not execute all test cases if you are testing a defect fix, or if there is a time pressure and you have to deliver a specific build in a very short amount of time. So you will prioritize, as we discussed in the first session, you will do risk based testing. So you will decide based on risk which test cases need to be done first and which can be left out in your test cycle. Apart from that, another reason why you will not execute all test cases is you may have too many faults which were found by earlier test cases, so they are showstoppers. For example, in an email application, you're having an issue with a login part, or you're having with an issue with loading your inbox. So these are all showstoppers. So then you will not be executing test cases and it will go back to the development team. Now when you in the test execution, you have to have a record of the various versions you're testing or the actual outcomes, and capture any new ideas for new test cases, and you have to keep records that all the activities have been carried out. And in test cases, in the execution phase, you compare your expected outcome, which was noted down in the test designing phase, and you compare that with the actual outcome, and you log discrepancies as a version fault, environment fault, or a software fault, or maybe the test run itself was incorrect. And when all the defects have been fixed, you repeat the required activities and have cycles. You will have multiple cycles in one release, and you will decide that in the time of test planning. Now they will come to the last phase, which is check completion. So test completion criteria were already defined in the test plan. So you have to say exit criteria, wherein you say that priority 1, 2, 3 defects are fixed, and you have executed all the high priority test cases, and say 50% of the medium priority test cases. And if you have too many defects and your coverage is too low, you go back to your specification phase and repeat, or if your coverage is okay, you continue. So now we will compare these tasks: planning, specification, execution, and recording. Now planning, specification, and execution, some part of all these are very intellectual tasks, and you have to do a lot of designing, a lot of thought process goes into that. There are many repetitive tasks. Say you have already logged a defect for the input fields in the application, and that probably is just testing with various types of data for each input field, and there are too many input fields in your application. So maybe that can be it's classified as a repetitive task. So the activity is repeated a good number of times, and that is the sort of activities or the test cases which you will think as good for automation. The top triangle of this is the intellectual part, is a one-off activity, planning and designing. So you need that will govern the quality of the test, so it's very important. The repetitive activity can be automated. That's it. Thank you so much.